Good morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do another code review, and this code review is going to be on Kaggle's Playground Series Competitions Season 3, Episode 21. And in this particular competition, basically what they want is they want you to improve a data set. Whereas in previous competitions, they wanted you to make predictions on the target. But in this particular competition, you don't have to make predictions on the target, but you have to improve the data set. And so basically, in order for me to improve the data set, I just removed the outliers, and that's what I did, was I removed the outliers. But I guess there's other things that you can do. If you know a lot about data sets, I guess you could replace variables. And if you replace variables to more homogeneous values, then that probably could improve the data set as well. But I didn't do that. The only thing I did was I removed the outliers. And what you can do is you can actually go onto the competition and you can look at the sample data sets that people have made, and you can see what they've done to improve the data set, and you can try that out. And I did actually just have a browse through some of the sample data sets, and I think I saw that somebody had said something about removing outliers, and I thought, well, that's what I can do. I can remove the outliers. So that's what I did. And I got a score of 1.55, whereas the best score was like 1.33. So I did my best, but I did get on the leaderboard, which is good getting on the leaderboard. So we'll go ahead and go through the code review about what I did to improve the data set by removing outliers. So the first thing what I will do is I will leave a link to the Jupyter notebook in the description box down below, so you can look at my code if you want to. So the first thing that we do is we go through the problem statement. Problem statement says, improve upon the data set provided and submit it to Kaggle for scoring on a random forest model. So that's what Kaggle's going to do. They're going to take your data set and they're going to put it in put it into a random forest model, and that's how you're going to get your score. And then after we've done the problem statement, then what we're going to do is we're going to import the libraries. And the way that you're supposed to do it in Python is you're supposed to import all of the libraries at the very beginning of the program. So that's what I did. I imported all of the libraries at the beginning of the program. So we're going to import NumPy as NP, which creates your NumPy arrays and carries out linear algebra computations. We're going to import pandas as PD, which creates the data frames in the series and processes the data. We're going to import OS, which goes into the operating system and retrieves files. We're going to, from scipy.stats, we're going to import z-score. That's what we're going to use to remove the outliers. From sklearn.model-selection, we're going to import train test split. So we're going to split the data set into training and validation sets. From sklearn.ensemble, import random forest regressor. We're going to check the data set out with a random forest regressor and see what we get. From sklearn.metrics, import mean squared error. We're going to use this particular metric to calculate root mean squared error. From import matplotlib.pyplot as PLT. We're going to visualize the data, and then we're going to import Seaborn as SNS. So we're going to statistically visualize the data. And so after we have imported the libraries, what we want to do is we want to set the seed for the program. So every time we run the program, it'll run the same. So np.random.seed42. And then what we want to do is we want to retrieve the files from the operating system using OS to do that. And the only file that we got was sample submission. So we're going to read the CSV files, convert them into a data frame. So df equals pd.read CSV, and then you got the link or the web address, the path to sample submission. And pd.setOption display.maxColumns none. What that does is that displays all of the columns, and now we've got df. So you can see df is 3500 rows by 37 columns. So that's what we've got there to work with. We're going to check for null values, df.isNay.sum. We don't have any null values, so you don't have to worry about that. And then we're going to analyze the data set. We're going to do df.info, which tells you that all of the variables are floats except for one is an integer. We're going to do df.describe, and that tells you the statistics of the data set. So if you're really good, you should be able to pick out some values that you can change to make it better. But, obviously I didn't want to do that. But the thing is that people who win these competitions, what they do is they go into the data set section of the competition and they look at other people's codes and they see if there's anything in other people's codes that they can use. And so this was the first time that we ever had a competition question saying to improve a data set. So I did my best. I removed the outliers, and I'm sure that there's more things that I could do as well. So now what we're going to do is we're going to define some variables. So dfid equals dfid, target equals dftarget, dftrain equals df.iloc, all of the rows, and then starting from the second column to the very end, and then dftrain. So now it just goes from target all the way to the very end. And now what we're going to do is we're going to analyze the target. So you can see that we've analyzed the target here. So that's what the target looks like. So now what we're going to do is we're going to detect and remove outliers from each row of data. The first thing we're going to do is we're going to detect the outliers. So it's outliers equals dftrain np.abs z-score dftrain greater than 3.all axis equals 1 outliers. And so it looks like there were not any rows where the outliers where the z-score was greater than 3. But what we do here is we remove outliers from each row of data. dftrain equals dftrain.np.abs z-score dftrain less than or equal to 3.all axis equals 1. So, and then dftrain index equals dftrain index, and then you check your dftrain index. So it got rid of quite a few. So the length is 2251. So it did get rid of quite a few. So we started out with 3,500, and then now we've got 2251. So this is your dftrain. It's 2251 by 36 columns. And you can see here we originally had 3,500. So you got rid of, well, definitely over 100 rows, and maybe more like, well, definitely over 1,000 rows, and maybe like 1,050 rows. So maybe in this particular instance, maybe I didn't have to get rid of all of the outliers. Maybe I could have just got rid of the outliers in the target. So that could have been something that I was looking for, was the target. So perhaps when I finish this code review, maybe I'll go through and try to do just the target and see what happens. See if that improves my score. And then we're going to define the x and y variables. So y equals df train target, x equals df train.iloc, all of the rows starting from 1 to the end, and then x. So you can see here's x. We're going to use train test split with sklearn to split the data set up into training and validation sets. So the test size is going to be 0.1, and then we print the shapes. And now we're going to use sklearn's random forest regressor to make predictions that's going to be the model. And so we're going to print the score, which is 64%, which isn't great, but hey ho. And then we're going to make predictions on the validation set. ypred equals model.predict xval, and then we print the score, so that's 51%. And then we calculate the RMSE, and that's 0.93. And then we use Matplotlib to check the RMSE. We'll check the actual values against the predicted values. So it doesn't look fantastic, but there you go. So now what we're going to do is we're going to develop our submission data set. So df train index equals pd dot data frame df train index equals df train index, columns equals id. So you've got your df train index, and then we check our submission equals pd dot merge df train index df train left index true, right index true. So you can see there's our submission file. And submission.tocsv is submission.csv, index equals false. Submission equals pd read csv submission, and then you've got your submission. And this is what we have submitted to Kaggle. And so you've got your ID, your target, and then you've got your 35 columns of data. But what I'm thinking that I might do when I'm finished with this code review, which will be shortly, I'm going to just go ahead and try to remove the outliers on the target and see if that improves my score. So there's always something that you can do to improve the score. So that's one of the reasons why I like doing these code reviews, because when I'm doing the code reviews, it gives me an opportunity to contemplate what I can do to improve the score. And sometimes it works and sometimes it doesn't work. So I'm going to go ahead and conclude this code review because I've covered everything we had to cover. And this is the first time we had a code review where we had to improve a data set. So I'm going to go ahead and keep working on improving the data set and see where I go. So thank you so much for watching my video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you to my subscribers for supporting my channel.